You need to know how to do this. Alright, so this is number 132. And asking for the shape of boron trifluoride. This one's going to be a little different. If you follow the steps that I taught you, you can get it. Follow the steps I taught you, and you can get it. Okay? Alright. How many valence electrons does a boron have? How many valence electrons does a boron have? Where would you find that? It has only 3. Okay? Look at the periodic table. There's boron, counting from the beginning of this row, 1, 2, 3. There's only 3 electrons. So boron then is going to have 1, 2, 3 electron dots. How many electrons does fluorine have? 7. 1, 2, 3, 4, 5, 6, 7. Okay, so fluorine is going to have 7. 1, 2, 3, 4, 5, 6, 7. And you put 1 on each side until you get 1 on all the 4 sides, and then you can pair them up. I've got 3 fluorines already. We already know that. And then I can share. Let me do it this way. I'm going to share here. I'm going to share here. And I want to share here. Okay. I'm going to do now from this, I'm going to get a Lewis dot formula. So we're going to squeeze the shared electrons between the 2 symbols. So between this boron and this fluorine, I have 2 shared electrons. I want to squeeze them in between there. Between this boron and this fluorine, I'm going to squeeze those 2 electrons in there. Between this fluorine and this boron, I'm going to squeeze those 2 electrons in there. Those electron dots. And then I have to put all the remaining electron dots around it. Okay. And that's called the Lewis dot formula. This is a sharing arrangement. We started with just the electron dot formula, and then we did this to show the sharing arrangement. Now that we've gotten to the Lewis dot formula, we're ready to try to find a 3-dimensional shape. How many sets of electrons are around the central atom? How many sets of electrons are around the central atom? 3 of them. 1, 2, 3 of them. Now, what 3-dimensional arrangement will get those 3 sets as far apart as we can possibly get them? A triangle. It's called trigonal planar. Okay? We put one up like that, one out here at 120 degrees, another 120 degrees. And put our electron pairs on there, because this is called VSEPR, valence shell electron pair repulsion. They want to be as far, those pairs of electrons, those sets of electrons, want to be as far apart as they possibly can get. And this shows that arrangement. Now, the next step is to take that same shape. And I'm going to put the electron dots on there. And I'm going to erase any set of electrons that is shared and replace that set with the atomic symbol that it's shared with. So each of these 3 sets of electrons are shared. There's no lone pairs on here. There are on the fluorines, but not on the central atom. So each of these are shared. I'm going to erase all 3 of these sets of electrons and replace them with the element, the symbol, for the atom that they're shared with, this fluorine. So I'm going to erase this and put a fluorine on there. Okay. I'm going to erase this. That's what I want you to do. This is the method I've taught you. Okay. What now? Yeah. Alright, put an F there. Now, I don't have any lone pairs left. If I don't have any lone pairs left, I'm done. That's the molecular shape. We just have to figure out its name. Okay, yes. Huh?
Is that even?
That would be even. They're evenly distributed. Okay? That's for figuring out polarity. You're right. Now, this then is an electron pair shape. That's the type of drawing, the type of illustration we have here. But that electron pair shape has a three-dimensional geometry name, and the geometry name is trigonal planar. That's an electron pair shape. And that makes this also trigonal planar because the shape didn't change.
What if I try adding those pyramidal things?
Hang on a minute. Okay? But this is not electron pair. There's no electron pairs on here. What are we going to call this? It's a molecular shape. If we're done with it, it's a molecular shape. Okay, so the question was, how is this shape different from trigonal pyramidal? Well, in trigonal pyramidal, we started out with a set of electrons that were like sitting up here. Okay? And then we had this sort of arrangement. We got it coming out from the board toward you and going back away from you. And then we erase the lone pair. So that's trigonal planar, a trigonal planar molecular shape. Okay?